Yes, from Mommy.
So, my question was, what will happen when we take KDNK, the Lift FM, on 100.5 and calculate the speed of all three stations and basically figure out which one's the fastest? And my hypothesis was that it would be 100.5 because it has the highest frequency number. And my materials were a radio, a tape measure, a piece of paper, a pencil, clipboard, and some flags to signify certain things. So what I would do is I would gather the materials that I needed, which was all these. I'd turn on the radio. I'd find the correct radio station. I'd walk away from the radio until I could not hear until the exact point where I couldn't hear it anymore. I'd flag it, and then I would figure out the distance between the radio and that spot where the music could no longer be heard. And then I would multiply the distance by 2. Then I multiply that by the station number with 5 zeros after it. And then I just do that with all the other stations. And I figured out that it was actually not quite how I thought it was going to be, because I thought how 100.5 was going to be the fastest, right? I was right about this one being the slowest, but I thought this one was going to be in the middle, and then this one was going to be the fastest, but I got these two mixed up. But I was pretty close. And I also did an observation chart, some research, and then I figured out, well, if I were to do this again, what would I do differently? And I decided I would probably just do the same thing, but with the same song on different frequencies, and see which frequency made it the longest wavelength and the fastest wave speed. And then here's the formula right here, which is speed equals wavelength times frequency. And that's why the multiplying the station number with 5 zeros after it by the I was just multiplying the length of the radio wave by the speed, by the frequency, and it was getting the speed, which was actually a lot easier than I thought it would be. And research, I did quite a bit of it. I figured out that radio waves are a kind of electromagnetic wave that can be broadcasted across space by means of electric current. Electromagnetic waves are a form of energy that has both an electric and a magnetic field. Radio waves are the weakest electromagnetic wave. Radio waves were discovered by Heinrich Hertz in 1888. The first radio station was founded in Pittsburgh in 1920. In order to broadcast a radio signal, the transmitter sends certain sequences of electrons up and down at certain speeds, and this sends a radio signal to a receiver, which sends it into the speakers that replicate the original signal with vibrations and turn it into sound. Yeah, it's pretty complicated.
You know what I'm talking about?
And other times where, say, you're just playing your iPod on a speaker, then you'd be actually just, it would take the electric currents from your phone, send it into the speaker in vibrations, and even just a normal phone has a speaker, so certain electric currents go into that speaker from your phone, and then
Right across from the
it
gallery.
plays the sounds
Back.
that it's supposed to. And
Big.
yeah.
As soon as I get the internet's up, he's supposed to send me a
Oh, I was gonna say, I based my experiment off of one in here to find the speed of the the little waves
Good there, look at it.
from the microwave that heat up everything. So what they were doing was kind of measuring distance between melted marshmallows and doing the same thing I was doing, but I decided to do it with sound instead, and it had these results, which are kind of cool. And the list I found was 12,039,876 meters. It went that many meters per second.
Yeah, again.
100.5 went 11,573,000 meters per second, and Katie and Kim went 8,612,782 meters per second. So yeah, they're pretty fast. That's pretty much it.
Thank you.
Now the
Want to say hi, Mom?
Hi, Mom.